Thanks for joining us in this optimization workflow. This is part 3 in a 5-part series. If you have not watched parts 1 and 2, they will get you caught up to our process of using FEM and Simcenter 3D and the value-based tokens to access the design space exploration solver. As a reminder, in this series, we will be looking to optimize a part that looks something like a leading edge rib for a lightweight solution without compromising the structure. In this video, we're going to work on the FEM and SIM. We'll define our materials and properties as well as set up how our part will react to our defined environment.
So we'll go back to our repost application and we'll create both the next two steps simultaneously. We'll create our FEM file and our SIM file. And then it's going to pop up our solution dialog, and we'll go ahead and create this. And it's going to add our load and boundary conditions as we create them. So if you look here in the tree, you now have this hierarchy, these assembly built. So this model drives the FEM drives the SIM. So as we make changes to model 1, it's going to drive the associative changes that are required in the FEM and in the SIM file. So we talked about changing material, position, and thickness. So now it's time to set up our materials. So when we manage materials, we can use locals or libraries. We're going to create local from a library. We're going to use an aluminum, stainless steel, and then a titanium. And we're going to copy these. And it's going to bring up a dialog box and make sure we pick our units. Simcenter 3D is unit specific. So we want our density and we want our modulus elasticity. And it's going to update those, and then it's going to automatically pull up my next material that I want to change or create locally. And it just cuts down on the clicks, cuts down on my workflow. And what am I doing next? Well, it's going to keep going until I've completed that process that I have asked for. Okay. So now we have our local materials ready to go. We'll hit close here. And we also want to create an expression like we did for the geometry for these. And this is the naming here is what's going to provide the link to heats. So you want to use the same name here that you want to reference in heats. And I'll explain why that is in a second. So we're going to create a placeholder, and we want to make sure that our material naming isn't going to be matching exactly what is going to be referenced. Go back into our expressions and set my materials, edit this value to be equal to our first material. So a really powerful thing of Simcenter 3 Inax and these tools is their ability to record scripts, and they call those scripts journal files. And these journal files can be recorded in your language of choice. So if we change our utilities, well, I guess it's preference user interface, you'll see that we can do C#, Java, Visual Basic, Python. And HEADS works with Python. So for this example, this is the part where the low code portion comes in. I recorded a file ahead of time, and everything in this file was generated by Simcenter 3D's recorder. Think the same thing you've heard about recording macros in Excel. And we only need to make a change to 5 lines in order to now automate the material modification process through HEADS. And here are these. So we're just going to assign the material. So these 5 lines right here, all that's needed to be changed other than what was automatically created. Okay, and I can help set that up from a particular project, but we're just setting variables to each other. Okay, so, and then the other file that's required by HEADS is just simply just call out that function that we defined here at the top. So within 5 lines that are modified and changing a name. We've got an automated process. Everything else is recorded directly from a session of Simcenter 3D. So we have our expression set up for our material, and we need to next. So that takes care of all the variables that we're looking to modify with heats. So now we're ready to create the actual nodes and elements. So we're going to create a 2D mesh of this part. I've already preset the size. Hit apply, and it has created a 2D mesh. And it keeps the dialog active in case you want to mesh multiple parts. In this case, we don't, so we'll hit cancel. So inside this 2D collector, we've got the property and then the mesh characteristics. So in our property, if you had inherited material from the solid, it would use that. Or you can go here and define your material. That's where you do that. So that's what that script is going to modify, that field right there. And we want to go and edit our mesh associated data and make sure that it's going to use our mid surface. So we can choose our mid surface. We don't want to evaluate every node. We just want constant thickness per element. So we'll do this at the element centroid. And we want it to automatically calculate our offsets for us. All right. So now we've created our finite elements, our nodes, applied our material, and our thickness is now tied to our mid surface. And that allows us to change all of our element thicknesses by changing the face offset of the solid. Okay. So we'll go ahead and save this. Next, we'll go to our FEM or our SIM file. So this is now where the last level, the highest level that will be used as the input file to heat. And we're going to create our loads and boundary conditions. So in this case, we're just going to create a force normal to a surface, and we'll pick our surfaces that we want. Say it's going to be 100 pounds, just for example. And we'll apply and we'll see, yep, is that the surface that we want? And is the direction and magnitude? Yep. So we'll hit cancel. We're not applying any more loads. Next, we'll apply constraints. And we're going to apply a user-defined constraint, and we're going to use the selection capability by using the smart selector method. And we can change our method to circular edges and input a tolerance. So we've got a circular edge inside that we do not want to keep. So we're going to change our tolerance, and we can pick our face that has our circular edges, and it will automatically pick and highlight which edges it picked to be constrained. We're going to just pin all these edges. So now we have our edges selected. We can change our degrees of freedom 1, 2, and 3 to be fixed. Now we set up pin constraints at all of our interface points. Okay, so that's loads and boundary conditions. And we set up the solution in the beginning. So our solution is already here. It's already got our active set from our constraints. We'll go ahead and save, and then we'll run the solution. Should just take a second to solve. Cancel and hit cancel. And then we'll go into our post-processing navigator, and we can create an elemental stress contour plot of the von Mises stresses. All right. So this is what we need. This now is going to be our baseline input to heats. So we're going to save this. And we can close the Simcenter 3D.
This concludes part 3 of our design space exploration workflow demonstration. Please subscribe for access to the playlist and for easy navigation to the other videos in this series. Thanks for watching.